都回来了吗？ You guys ready? Good. Let's go. 看人又来了哦。直接把这号钱包先拿出来。Right, let's start the third round. The opponent challenges the reporter for the problems. 1 minute.
Okay, we would like to challenge problem number 6.
Accept or reject the challenge. 1 minute. We accept. Accept. Preparation of the reporting. 5 minutes. Presentation of the reporter, 12 minutes.
Hello everyone, I'm the reporter of TYPT. Today I will report problem number 6, Kingsford Tower. So first is the problem statement. Build a tower by stacking tennis balls using 3 balls per layer and a single ball on top. Investigate the structural limits and the stability of such a tower. How does the situation change when more than 3 balls per each layer and a suitable number of balls on the top layer are used? And this is my main box. What is the main factor to keep the tower stable? And the next is what is the limit of the tower? The third is what is the stability of the tower? And this is my content. First is the observation. In my observation, I have 3 types of towers. First is basic tower, and the next is pyramid. The third is spatial tower. And first part is my theory. Before I start my theory, I want to introduce the software I will use in my theory and analysis. The console motor physics. And this is the process I use this software in my theory and analysis. So first, I want to discuss in my theory. I want to discuss the basic tower. First is basic tower about 3 balls on bottom. So first, I want to introduce the equation about this type of tower. First, I will discuss the ball 1, and ball 1 is this. And the next part is the ball 2. So we could gauge these three equations. So according to these 3 equations, we could gauge the formula of the mu1 and mu2. And the mu1 is the coefficient of friction between ball and the surface, and the mu2 is the coefficient of friction between balls. And according to these 2 equations, we could gauge the value of mu1 and mu2. So this is a situation that the tower will collapse and the tower will not collapse. In this part, I will discuss the model of the 4 balls on bottom. And although the concept of equation is same, but the part of the number will a little different. So according to these 2 equations, we could gauge the value of mu1 and mu2. And also, we could use the console to simulate these 2 situations. And this part is the model of the 5 balls on bottom. And also, the concept is same, but the part of number is only a little different. And we could gauge the mu1 and mu2. And this we also can simulate these 2 situations. And next part, I want to build 6 balls on bottom. But when I started building this type of tower, I found that the area between balls is enough to put a ball in it. So we could know that the tower can't be built, and I can use the console to build a model like this to prove this observation. And next, I want to discuss if the tower collapses. There are 2 situations. First situation is if N2 increases slowly. According to this equation, because the next port is same, so we could know the F1 is F2 and I suppose it's F. So if we start increasing the N2, the tower will be more stable. But if we increase N2 more and more, the tower will collapse. It's because that's the maximum static friction. The maximum static friction is not unlimited. And this part is the second situation is if F1 is not equal to F2. what will happen. According to this part, because F1 is not equal to F2, so we could guess this. We could guess this question about N1 and N2. So this is when the tower collapses. And next part is my experiment. In my experiment, I want to compare with the brand new ball and the element ball. So according to this experiment, we could know the maximum state friction, the value of maximum state friction of all the ball is bigger than new ball. And next, I will discuss the stability of the basic tower. According to the video, we can know the angle causing its stability is 25 degrees because the ball has the ball moved a little. And the next part is the stability of the four ball. And also the angle causing the instability is 30 degrees. And in here is the 35 degrees. So we can know the most stability tower is the most stability tower or basic tower is the 5 volts on bottom. And next is my analysis. In my analysis, I will analyze the force picture. So here's my type of tower I will use in my analysis. First is the pyramid, and the second is the same numbers of balls at each layer. So this is the pyramid I built. So I can use the console to build the model like this. And first I will discuss the bottom layer. So the red direction is the normal force of the lower ball, and the yellow direction is the normal force of both ball, and the orange direction is the friction force. And the next part is the second layer. So the direction of the friction will be different because I discussed the second layer. And next part is the top ball. Because my size is different, so I use number to display my size. And next is the ball on bottom, and here is the ball layer. And also the yellow direction is the normal force of ball, and the orange direction is the friction and next is for second layer. So also the direction will be different because I discussed the second layer. And the next is the third layer. And the next is the top ball. And also my size is different, so I use number to display my size. And next part is the same number of balls as each layer. And this video is the way I built this type of tower. And the 8th layer is the highest tower I can build. Is like this type of tower. So I can use the console to build this six tower. And I discussed this friction. This is force picture. Also, the red direction is the normal force of force ball, and the orange direction is friction force, and the yellow direction is normal force of both balls. And next part is the second layer. And the next is top ball. So also my size is different. So I use number to display my size. And that is ball on the bottom. And this is the situation 4 layer. And this situation will be same like the 3 layer. And the next part is ball on the second layer. And the next is the ball on third layer. The next is the ball on top. I only discussed these two in pyramid, and this type of tower I only discussed these two types of 3 layer and 4 layers, because when we build a more high, the situation will be same like what I draw. And next part I will discuss if we remove the top ball, what will happen. So you can see this video. When we remove the top ball, the drop order will from top to bottom. It's because when the top ball was removed, the second layer didn't have enough friction to support it. And that's my conclusion. First is friction is an important character which makes the tower stand. And the second is in the case of basic tower, if the number of balls increase, mu1 and the mu2 will be bigger. And third is in the case of basic tower, the more balls adds to the bottom, the tower will be more stable. So this is my
Questions of the opponent to the reporter and answers of the reporter. 2 minutes.
Can you please go to your your beginning where you calculated mu1 and mu2. So your 3 calculations using 3 balls at the bottom, 4 balls at the bottom, and 5 balls at the bottom. Why is the mu1 different? Is your friction coefficient different in each calculation? Yes. Okay. Can I take that as a yes?
yes.
Okay. Okay. So at page 33, 38, and 41, why didn't you consider the friction force at the bottom layer? Sorry. Did you consider the friction force at the bottom layer?
Sorry, can you?
33, 38, and 41. Whatever page.
Because if the
Did you consider? Yes or no?
yes.
Okay. Then did you consider how the surface of your where you put the tense ball on? Did you consider how it will affect this phenomenon? Yes or no?
Maybe yes.
Maybe yes. Could you go to page 45? Yes, the video where you take off the first ball. Yes. What's that mat under the tennis ball tower? What's that mat? There's a black mat.
Oh, it's the sandpaper.
Okay. And at page 19. Sorry. What do you think is the most important parameter here that will affect its stability?
Right, time's up. Preparation of the opponent. 3 minutes. Opponent gets the floor maximum 4 minutes and followed by discussion between the reporter and the opponent.
Okay, so, I'm Joey from team Navigator, and I'll be the opponent for question number 6. There's a problem statement, and we believe that the crucial point here, so first we have to discuss about the layer numbers, and then whether there is a limit to it, and also when it is stable or when it's unstable. And the most important aspect here will be the friction force, because without friction, this phenomenon would not happen. Okay, so the summary of the report. The pros are that it has many charts, and it has many videos and their experimental their pictures, so that we can clearly see what the motion is and how it will affect the phenomenon. It gave clear explanation in the theoretical part. And however, there's no experimental data, and there is little connection between the data and theory, and it did not mention the structural limit, and which the problem statement requires. Okay, now to the main focuses. Okay, so we will be discussing on this. So the phenomenon explanation. So there are 3 types: basic tower, pyramid tower, and 2 types. And we'll be discussing whether there will be a limit of layers. And they also showed how the tower collapsed. And we'll be discussing what they believe is the main factor, and how do we define stability. And that is, for example, when you do the experiment, if you remove the top ball or remove the bottom ball from the side, would the force of your hand actually affect its stability? Can you ensure that it is not that the force is uniform? All right. So to the theory part. First of all, I would like to point out that the coefficient of friction, between different surfaces would not change. So the coefficient between balls and balls would not change, and so would the coefficient between balls and the surface would not change. And so friction is vital. So without friction, it wouldn't be we can't build a tower, and there won't be a stable status. And so theory, top layer falls, and then followed by the second layer, and a different ball surface coefficient Yes, and the different bars surface coefficient will be different because they are using old and used bar. So each bar is slightly different, and also they did have a lot of force and analysis. And however, they did not show a clear demonstration to the force that causes the tower to collapse. To experiment method, so they use this software, and they try a new bar and old bar, and we believe that old bar can do this experiment better because old bar has a greater coefficient of friction, but they did not measure the actual frictional force between the bars, which we think can be done. So the parameters will be the different bars and how many layers are there and what type of tower they are going to build, and how the limit what thing will affect the limit, and can we actually stack it to a infinite tall. Okay, I'd like to start my discussion. So, could you go to the point, let's start with our mu1 and mu2. So go to the place where you calculated mu1 and mu2, yes. So here you calculated mu1 is 0.0795, can you go to the next one? So this is 0.0828, can you go to the next one? And 0.093. So mu1, as I understand, is the coefficient between the bar and the cable, right?
Yes.
And why? Can you tell me why the friction coefficient will be different in this scenario?
It's the minimum value of the surface between the surface and the ball.
Oh, I understand. So it's a minimum coefficient that it requires for it to stand up, right?
Yes.
Okay. Okay. So next question. Did you actually measure like for each ball what actually so because here I understand what you're trying to do. So you're getting a basic required coefficient for one layer or two layer, and however did you actually measure the coefficient of friction between each ball?
I didn't do it, but I think I can do it in future.
Yes, because what I believe is because you said that the best three ball per layer tower you can do is 8 layers, right?
Yes.
Yes. So if we draw a force diagram, then maybe we can get the minimum coefficient we need by using the same method here, by using similar methods, and then if we can measure the coefficient between bars by simply sliding the ball against each other and testing how much force it needs, then we can have a prediction for how many layers we can actually get, right?
Yes.
Okay, so let's move on to our next question. So can you go to page 25? So here you're trying to you're trying to drop it from different angles, right? So that it will create a different impulse. So the higher the angle is, the impulse to the ball will be greater, right? Yes. So, however, did you consider to actually calculate the impulse it creates?
I think I didn't do it, but because I think we can use angle to display
Yes.
to compare the force of.
Yes. Okay. But what I'm suggesting is that because since we have the mass of the ball, we can measure the friction coefficient, so we can actually calculate if I give a horizontal force in this way, then what is the maximum horizontal force I can give before it falls down? So that would be, I think that would be a point where you can actually calculate out the numbers. And also, did you hit it at the same point? So like, is it all on the center of the circle?
Yes, I hit the center of the circle.
Okay. So okay, let's move on to the next question. Could you go to page 19 and 20? Page 19. 19. Just some clarification. The video is pretty unclear. Did you push a ball down, or did you just follow the ball down?
I push the ball because the tennis ball can't display this phenomena easily. So I use my
Yes.
hand to.
So what are you trying to tell us here?
Because I tell us the. Because I want to display this phenomena is the tower will collapse.
Okay, so I'm guessing you're trying to calculate the maximum force before it collapses.
I want to show how I want to show if the tower collapse. What is
The forces.
I want to display if the tower collapse. What is this size? What is this? What should?
Okay. So I'm guessing you want to calculate force. So maybe you can put mass, like for example, mass on top of the ball, so that you can actually quantify what normal force I guess. But however, we can move on to the next question. What do you think is do you think there is a limit to this tower? So do you think I can stack it up infinitely? Yes. So what I mean is that you said 8 layers what you can do, right? Like
Yes.
But do you think there's any way we can stack up to 20 layers, or like just going up?
Maybe yes. If I didn't if we change the way I built, I think we could find more better ways to.
So do you think lighter weight is easier to build a tower, or heavier weight? It's okay. Let's move on to the next question. So besides the balls and balls, besides the interaction between balls, there's also the interaction between the balls and the surface, right? And as seen in page 45, you actually put a sandpaper so that you increase the frictional force or the frictional coefficient between the ball and the surface, right? Yes.
The reason that I put the sandpaper is because I can build the tower more easy.
Okay.
The tower will not move. During I build the tower.
Okay. So did you try, like for example, if I increase if I let the sandpaper have an even higher coefficient, then will I get a higher tower?
I think this may be better, but not very much, because when we build the tower more high, the normal force between the bottom ball of the surface will be bigger. It's because the N1 will be the normal
force will be bigger.
Yes.
And so will the frictional force, right? Yes, but okay. So let me ask you this. So if I build any tower, whether pyramid or this kind of tower, so if you're saying that the normal force at the bottom will be greater, but F equals the frictional force equals the coefficient times the normal force. So if the coefficient is the same, then the frictional force will be greater, right? But so the greater the frictional force you have, it's easier to hold up the tower. So why would it collapse and keep building?
When we build the tower, the reason that the tower will collapse is because it's not because of the bottom, but because when we build maybe second or third layer.
So which layer do you think is most unstable? Most unstable, which layer is what determines whether this tower will stand or will fall?
I didn't investigate.
Okay. But from your okay. So what I was trying to say is because of course we cannot build this to a unlimited range. Okay. So the question asks us to use tennis ball, right? So if the normal force is great enough, the tennis ball will dent, right? It will have a dent, and then your phenomenon can no longer explain, or your theory can no longer explain it, right? Is that true? Yes. Okay. Yeah.
I thought the opponent summarized the discussion 1 minute.
Okay, so in our discussion, we clarified what his coefficient of friction in calculated means, and I gave some suggestions of how he could quantify how exactly the force needs, or what exactly the coefficient is, so that we can estimate how many layers we can get. And also, they say they didn't give a clear explanation on why there will be a limit to the tower. So that would be because of deformation, and lastly, yeah, that's it.
Right. Questions of the reviewer to the reporter and the opponent, and answers
Okay, first,
to the question.
from that, work your opponent, and I have a question for you. Since it is a tennis ball tower, do you think that the elastic properties of the tennis ball tower will affect the phenomenon? The elastic properties of the tennis ball, yes or no? Yes. So you do think that it will affect the phenomenon, but you didn't show it. Okay. Now, for the opponent, what do you think?
Yes,
yes, of course. Okay. Now, the next one is the effects of the bending moment. Since every object that when it has a force on it, it will create some internal torque inside the structure. So, do you think that the bending moment of the tennis ball should be analyzed for further explanation of the phenomenon?
What about the opponent? Okay, so I believe that we should consider, because that would be the reason why it has a structural limit. But if it's only like 2, 3, 4, 5 layers, the force of the tennis ball is not enough to create enough then to create an.
Okay, thank you. And what about
enough
the floor?
I think it can be discussed, but I didn't.
Okay, thank you. And now in your presentation, you stated that you have used old or new balls, but since do you think that all tennis ball in your tower is about to be the same? Because in your model that used your analysis, you assumpted that all balls you use are the same. So, do you think that all old balls that you use are the same? That use the same time, in the same place, in the same condition? If not, then how can you use your old ball to do the phenomenon? Thank you. And the next one is for you again, reporter. Do you think that the properties of the table except the properties of the table, except the friction, do you think that the properties of the table have other effects on the tennis ball tower?
I think maybe yes, but not very.
So you think so, but you didn't know. Okay. Now, the last problem is, what is your quantification of stable? What is a stable tower? Because you didn't mention it. You just said that sometimes it's stable and sometimes it's not. So, what kind of tower is stable?
Maybe I think it's like pyramid. I think it's pyramid.
So you think that only pyramid tower are stable?
Not but there are many.
Time's up. Preparation of the reviewer, 2 minutes.
Dear judges and award opponents, I would like to start my presentation. Good evening, everyone. I am the reviewer from the team Latasha, and now it's a purpose statement. I will not elaborate on that furthermore. And the focus or purpose are what are the main factors in play: the limit of the tower and the stability of the structure. And the reviewer's thought is that the material elastic characteristic of the ball is important too, and we should focus on that. And for reporter, their phenomenon has shown, their theory is their static equilibrium. The experiment they use stack tennis ball and console simulation they use in their presentation. Their strengths are their clear demonstration of phenomenon, and they recognize basic assumptions made about friction. But their weaknesses are their lack of quantitative results. They did not consider limitations of their theory, as in the limitation of the tower height. And they have no theoretical prediction of, again, at the limit of the tower's height. And they did not specify how to quantify angle causing instability in their presentation. Now, for the opponent, they have their clear presentation, and they discussed many plausible parameters, but they did not elaborate on the method for quantitative experiment as the reporter lacks, and they have not enough discussion on their theory. Now, in the discussion, the opponent asked, the calculation of mu1 and mu2 show different results, and the reporter says that result is the minimum coefficient required. The reviewer has no comment on that. The next discussion is that the measurement of the coefficient of friction between balls, the reporter says that it can be done in future experiments. And the reviewer, we think that this is an important factor for quantitative theory, since the force that drives the tower to be stable is the friction. So we have to know what the quantitative status of the friction. Now, next page. Angle, the owner says, angle causing instability. The reporter calculate the impulse given by collision. The reporter replies, no, because the angle is enough. The reviewer agrees with the opponent. The force needed to destabilize can be important. So we suggest that the reporter could do further experiment on that. Now the next one is the influence of weight of balls. Why does it collapse? The reporter says they have not confirmed the problem. And the reviewer says that the weight will have an effect, but a combination of forces make the result hard to predict. We need to consider the elastic properties of the material, and that makes the problem further harder. And now we move on to our session where the points missed by both the reporter and the opponent. the first one is the definition of stability. Since the problem statement that suggests that we have to find a stable tower, so we have to know what kind of tower is stable. Is it stable for 1 second, or can we put it like for very long and it is still stable? And what kind of structure can be stable? The next one is the elastic properties of tennis balls and the affection of deformation. Since if you put force on the tennis ball, it will create a dent and it will affect the stability. And the next one is the internal stress and the strength and the bending moment of this, as I has elaborated before. And the next one is the theoretical height of tower versus experiment. The next one is the reviewer's suggestion of theory as in finite element analysis. That is a analysis method to analysis of a material that is tend to bending, and analysis we can suggest that all the surface of the material to be point of mass, and to throw it into a program, we could analyze the result better. And the next one is what is the optimal structure of the forward-tallest tower and limitation of stacking in theory, and the effect of torque on stability, as the reviewer has elaborated before. So we will not say this very more. And thank you, everyone.
Concluding remarks of the reporter. 2 minutes.
In my concluding remark, I first highlight that I use the console simulating to simulate the tower will collapse or not collapse. And the second is using white with different angle to check the stability. And the next part is we could try to make every ball surface the same. And next we should also notice about the deformation. And I think I can do more things in the future is the thing I can do in the future is we can measure the maximum coefficient of friction of the new ball and the old ball to display my observation more clear. Thank you.
Right. Time for questions of the jury.
I have a question first for the reporter. It seems to me you use the pendulum with the web to check the stability, as you said. If you use the pendulum to hit the structure,
Yes.
and hence you define your stability in that way, right? But I didn't see that data for all different kind of structures. Have you shown that?
I did. I think I can measure it.
Okay, thank you. And for the other two, and I wonder what kind of suggestion you would have in terms of experimentally define the stability.
I have 2 ways. So the first would be just to stack it up and see if it falls. But this way, the bad thing about this way is because we cannot control whether the environmental gives some shake or something, and then we cannot quantify that. And but if we use a reporter's way, then we can, for example, hit the hit the top bar of each tower, and then see what force it needs for it to fall.
Thank you.
Yes.
Any other questions?
The reviewer agrees with the opponent that if the tower is stable, the balls wouldn't fall down. Yeah.
But I'm stability.
Oh, the stability.
Stability.
We think that if a tower is stable, maybe in the ball, if we divide it into many little points of mass, if it is stable, maybe the point of mass won't move for a duration. And if we observe that phenomenon, we can say that the tower is stable enough.
Other questions? Please.
I want to ask the reporters what's the highest the layer you got? Is it 6 or 8?
8.
8. Okay. Okay, great. Okay. if you increase the mass of each ball, okay, you got to optimize the maximum height is 8. If you can increase the mass of the tennis ball, do you think you will get more layer stable or less layer stable?
I think maybe,
Or nothing?
I think maybe yes.
Okay,
Because the more mass will cause the maximum saturation will be bigger.
how about?
If every other aspect is the same, so including the deformation of the bar is the same, so it doesn't bend more, then it wouldn't have any change because it will only be changing the normal force that it provides and the frictional force, but no still will increase.
So there's no effect.
Yes, together.
The reviewers think that by increasing the mass of the tennis ball, we may have certain effects, like we will increase the friction caused by the tennis ball tower, and we will notice a more dent in other tennis balls, and and furthermore, the increase of mass will make more normal force. So we cannot know for sure if increasing the mass of the tennis ball tower will increase the stability or not. So we have to do many experiments to know that for sure. Yes.
Possible. Both ways.
Yeah, both ways possible. We think that.
Okay, thank you.
Any other questions from?
Yeah, just a short question for all the audience. Okay, so if you can repeat the experiment, how can you, do you have any idea to provide a quantitative descriptions about the load and the friction force? Do you have any idea? If you can repeat the experiment. Description. Quantitative description about the load or the normal force and the friction force. Do you have any idea to measure that? Yeah, maybe reporter first.
First, we would like to, because we have to give a quantitative model, right? So we will going to measure the coefficient of the bar, and to relate to the bar and relate to
how to measure?
One way is if we can, for example, is there a ball? So if we can pull the ball on the surface, then we can measure the force that it needs. Yes, and but however, a better way would be to cut the ball out and then just use like a flat surface out of the tennis ball and then to press it and then move it.
We think that measuring the relevant parameters of the tennis ball, we can in some way know the quantitative result of the stability of the tower. Just like the opponent said, that we could measure the tennis ball's friction, but we think that since tennis ball is a ball, so it might roll on the way. So we think that it is not that easy to measure the friction, and we have to think about the ways to measure.
So you have no idea about it?
We have some idea. Maybe we can put a string on the tennis ball and put it along the way and see how much force can vary to move it, or experiment method like that. But we need to do more further research to know for sure.
Okay.
I think yes. I can measure at least number to measure maybe the limit height or any experiment data in my experiment.
Okay. Thank you for the fruitful discussion. So jury, please mark your grade. Right, so the grades for the reporter: 7, 4, 6, 5, 4. And then grades for opponent: 7, 6, 8, 7, 6. And finally, grade for reviewer: 8, 7, 7, 7, 8. Okay, thank you for all participants and jury, and I will close the fight.